Welcome to 5 Good Questions. I'm your host, Jake Taylor. Our guest today is Samuel Arbesman. Sam is an applied mathematician and network scientist and author of the book, The HalfLife of Facts. He's a senior scholar at the Kauffman Foundation and a fellow at the Institute for Quantitative Social Science at Harvard. His writing has appeared in the New York Times, The Atlantic, and Wired, among others. Sam's got an extremely wide knowledge base, and I'm excited to ask him 5 good questions. Welcome back, everyone. My guest today is Sam Arbesman, the author of The HalfLife of Facts. Sam, where are we talking to you today?
I'm in Kansas City.
Great. I'm actually really excited to talk to you today because, reading your book, I was really impressed with how wide-ranging it seems like your interests are and how that has come into the book. This isn't a super drilled down academic type of thing. There's some great stories in there.
Oh, thank you very much. I'm glad. I appreciate that.
So, Sam, let's jump right into question number 1. So, before Copernicus, the universe was revolved around the Earth. Before 1956, scientists thought there were 48 chromosomes instead of 46. New studies come out all the time about what's the correct diet for humans that's the most healthy. It seems like the facts of the world are changing all the time, and maybe at an even quickening pace. As a rational, or attempting to be rational human, how do I keep up with that change of pace? And there's just so much information out there. What do we do?
So you're right. It is extremely overwhelming, and there's a lot of rapidly changing information. And so I have a small daughter, and when she was born, I was exposed to how much information previous generations thought was true about raising babies, how it's all been overturned. So you see this in baby raising, you see it in nutrition, you see it in things we learned about what dinosaurs look like. You see it in pretty much every area, like technology, science, and all these things have changed. And I think it can be very, very overwhelming. I think one of the ways of thinking about it, and actually one of the reasons I called the book The HalfLife of Facts, is because there's this idea that there is, even despite all this flux and change, there is an underlying regularity. And so I use it. You can think about this along the analogy of the half-life. So in physics, within radioactivity, if you are trying to predict when a single atom of a radioactive material, so let's say a single atom of uranium, when it's going to decay, you really can't predict it. And it could decay in the next fraction of a second, or you might have to wait millions and millions of years. But it turns out things change when you go from having a single atom of uranium to a whole chunk, millions and millions, or huge numbers of atoms of some radioactive material. Suddenly it goes from being unpredictable and random and kind of overwhelming to actually being completely regular. You can actually calculate the half-life, how long it takes for half of these radioactive atoms to decay. And you can't necessarily predict which specific atom is going to be in that half, but overall there's a regularity. And I think the same thing is true with how we think of knowledge. Even though I might not be able to predict which specific discovery is going to occur or which fact is going to become overturned in the next few years. Overall, there is a regularity. There are rules to how knowledge grows, how it changes, and I think those are the kind of things that we can use to kind of place bounds on our surprise. So one of the ways is to kind of get a sense. Okay, what are these half-lives of different fields? What are the rates of different fields? And the other thing is also, it's less about memorizing lots of facts because they're going to be overturned quickly, and more about kind of knowing how to kind of explore information. So in recent years, a lot of people have said, with the advent of the internet and Google, and people's memories are declining and people are just kind of looking things up. And my response is maybe that's actually not such a bad thing. Maybe it's okay to say, well, rather than having some half-remembered fact from some magazine article you read 5 years ago, which is probably
obsolete now.
It's not true anymore. You could say, well, maybe maybe it's better to actually look the thing up online and find out the newest bit of information. And thinking that technology is hurting our memories is not new. And there's a lot of ancient Greek philosophers who said that, like, oh, with the advent of the printed word, then our memories are going to be ruined. And maybe that's true, but I think the printed word is kind of awesome. So that's okay. I think the same thing is true with these technological tools that allow us to have access to new bits of information. And I think, and you can, and one of the areas where I kind of look to kind of guide us to kind of think about how to deal with rapid change is medicine, because medicine changes incredibly rapidly, but it's also very important to have the most up-to-date information because lives are on the line, and you want to make sure you're giving people the right treatment and making sure they don't die, that they can be treated and become healthy. And so in medicine, you have continuing medical education. You have these certification processes where physicians have to relearn things on a regular basis and make sure they're actually staying up to date. And I think, there's even there's a website, a medical website called Up to Date, which is it's updated by experts in different fields on different topics, and so it's guaranteed to kind of have the most up to date information in whatever field. So, because if it's not your domain, let's say. If you specialize in cardiology, but you want to kind of understand something about the skin, you're not going to necessarily have the most up-to-date information. Chances are the last thing you learned about the skin was in medical school, and that might be 20 years ago, and it's changed. And so having these kinds of resources is incredibly important. And I think recognizing that, first of all, there is a regularity to how this knowledge changes, but also that there are tools that we can use to kind of handle it. And also just being willing to say, okay, maybe I don't remember exactly what the fact should be. I'll just look it up again. I think that's okay. I think that there's nothing wrong. And I think that might be this kind of recognition of this rapid change is probably the first step in actually being able to handle it. Yeah.
So it's a good segue for question 2. Is there anything about a specific field, whether it's, what characteristics about a field can kind of maybe give us a hint as to how quickly the information in that field decays?
So,
like metadata of some kind.
I think it's a hard question to kind of answer in a very, very clear way. I think there's a few different hints and a few different ways of thinking about it. So one is, and certainly within fields, the more popular a topic is, the more likely things are to be overturned more rapidly, because there's lots of people studying it. So it's not necessarily saying that, the more popular something is, the less likely we actually know anything about it. It just happens to be that there are more people scrutinizing that field, and so therefore there's going to be kind of a greater churn as we kind of hopefully at least approach the truth.
Asymptotically.
Exactly. I think the other thing is also related. I would say one is maybe related to the age of the field. So when a field is young, like a discipline is young, there's a lot of low hanging fruit. There's kind of these there's discoveries to be made that are really that are large signals. They're very easy to find these discoveries, and I think those discoveries they're more likely to stand the test of time. As you have fields that are either become older or fields that deal with things that are noisier. So often, a lot of the social sciences, when you deal with people are, we're not like billiard balls on a pool table. We react in kind of random and capricious ways. And so therefore it's going to be a lot noisier. And I think when things are noisier, then there's going to be a lot more situation where people think they've found a discovery, but it actually might just be due to some sort of statistical anomaly. And I think, so my sense is the kind of social sciences are a little bit noisier. And so there's going to be, and you're kind of finding things where the signal to noise ratio is such that you might be finding things that you think are signals, but are actually noise. The other thing is also, just kind of other areas, and so with medicine, another thing with medicine is not necessarily that the facts are becoming overturned and that we thought this thing was true about the human body and we now realize it's wrong. It's more certain things are just obsolete. So what is the best treatment for something? That's just obsolete. So there's I would say in terms of like truth versus untruth and obsolescence, there we kind of I think in the book I kind of combine these things together. They're all distinct, and the reason I combine them is because it turns out they often change in the same way. There's kind of nice regularities to how all these things shift in terms of how we think about beliefs and obsolescence and truth. But there are different ways. And so when it comes to medicine, for example, certainly obsolescence is a big factor. And the more money and effort being poured into a certain area to try to make new treatments or new technologies or whatever, then the greater the chance that, things are going to become overturned more rapidly.
Right, that little incremental gain that has a little bit less side effect, that becomes the new, standard. And
Exactly. I would say on the opposite extreme, probably the kind of field that I would think is probably on the opposite extreme, that where most of its discoveries would, or kind of findings would stand the test of time, would be something like mathematics, where like, you prove something, and unless someone finds a mistake, that proof stays. It stands the test of time. That's why you can read Euclid, right? And I think he lived like thousands of years ago on geometry, and his findings are still the same. I mean, angles are angles, and triangles are triangles, and and you can modify and say, oh, well, let's say we have a different geometry. Instead of being kind of planar geometry, we'll do something like on a sphere. But that's more kind of an addition as opposed to saying, like Euclid was wrong. So I think those kinds of things definitely more likely stand the test of time.
Question number 3. Big data is a very hot topic these days. How does the half-life of facts fit into this concept of big data?
So one of the things I discuss in the book is about, so as we create, generate more and more data sets, like these huge big data sets, and one of the things we need to be mindful of is that if there's any sort of bias in these large data sets, like in terms of like what we're like, and the kinds of data we're collecting, it's going to become magnified when it becomes big data, and that will have implications for the kinds of things that we think are facts or the findings we have. So, for example, in biology, a lot of findings about different species are not necessarily based on like surveying all the species on the Earth equally, evenly. It's kind of, again, it's the low-hanging fruit. The things that we know most about are the things that people find most interesting or easiest to find. So it ends up being that I think the vast majority of papers are about, at least when it comes to kind of animals, are about vertebrates, like the ones with kind of spinal cords, because they're the ones that we think about. And I think actually there's one person, so there's this thing called taxonomic bias, which is that kind of what I'm discussing right now. And I'm trying to remember that this is, and I think I described that correctly. And there's one extreme that some people even refer to as taxonomic chauvinism, when people are focusing on certain areas. I think they were discussing how there's not enough papers about reptiles. I think about reptiles and amphibians because people think, oh, they're kind of like squishy or kind of creepy creatures, and so therefore they've been like, we don't actually know as much about them. So in terms of how knowledge grows, there is kind of these weird, interesting biases in how we generate data, and you can actually see this with dinosaurs. And so kind of the most well-known dinosaurs, and some of the most well-known ones are the Tyrannosaurus Rex, Stegosaurus, Triceratops. And it's not because these are necessarily the ones that are the most bountiful, during the time dinosaurs lived. It was because they were actually some of the first dinosaurs discovered. They were the easiest ones to find. And I think that those kinds of things can that can bias us in how we think about whole fields. And of course, as we discover more, that might give us a better picture. But we need to make sure as we generate big data, it becomes it's evenly distributed to make sure the kind of discoveries we're making reflect the underlying field. And the other way that big data, I think, plays a role in the half-life of facts is actually related to how we is related to just the vast growth in scientific publication and scientific papers. And so now, as we the number of scientific publications, it's growing exponentially rapidly. There's a huge number of scientific papers, and there's no way anyone can read all the papers that are out there in science, let alone even in their own specific specialty. And so when this happens, it means that there's a lot of knowledge out there that we just don't know about it. And so I discuss this as hidden knowledge. And actually, one of the amazing examples is there was an information scientist. He actually passed away recently. His name is Don Swanson, and he back in the 80s he explored this idea of what he called undiscovered public knowledge. And so he created this thought experiment, and he said, imagine there was some paper in some area that said A implies B, and there was some other paper, maybe it's in the same discipline, maybe it's in a totally different field, that said B implies C. Unfortunately, due to the vast amount of the scientific literature, there's no way anyone has actually ever read both these two papers. So even though it might be true by combining them that A implies C, no one knows this, just because the literature is so large. And so he said, well, maybe we could use computers to try to help automate some of this process, kind of comb through these vast data sets and this vast amount of scientific knowledge and information. And so he was not content making it a thought experiment. He tested it. And so this is in the 80s. And so the way he did it was he used search terms in like an online database, and he was able to actually find, if I'm remembering this correctly, a relationship between a circulatory disorder called Raynaud's syndrome, and he found a treatment for I think involved taking some vitamin supplements. I can't remember exactly the details, but it was this thing that no one had really known before because he combined literature that was previously disconnected, and then I think he eventually published it in a medical journal. And so now this kind of process has become massively automated because we now have tools to kind of sift through this and big science and actually kind of work through all these different things and see how it all becomes
fits
connected
together. Yeah.
Yeah, and so I think the kind of the potential for computers helping kind of uncover hidden knowledge is one of these kind of unbelievably exciting things. And so whether it's kind of connecting papers or finding like the relationship between a gene and a potential disease or a disease and a potential treatment, I mean, these things have now become automated, and there's a lot of really, really exciting things on the horizon. So that's great. So I think that's certainly one potential thing that is involved in the half-life of facts and big data.
Yeah, that's super cool. I like that a lot. It almost takes like Charlie Munger talks about a man with a hammer. Every problem looks like a nail, and this is like the inverse of that. Basically, like we're really trying to find putting different tools together to solve problems.
Oh yeah, and I think this is, and if you see it, like if you look at the literature, you can see this kind of thing happen over and over, where people, because the scientific literature is so big, we end up rediscovering the same things over and over and just call them by different names. And so if we can find ways, and sometimes we need computers to help us to do this, but find ways to kind of almost run an import-export business of knowledge and say, okay, something in this field is actually really relevant to this other field, rather than saying, okay, this one technique is like, I'm just going to keep on using it over and over and over for everything in my own field. Actually saying, let's try to find a way to kind of show how these different things can be spread between different fields and make them more useful, I think can be really, really powerful.
Yeah. So question number 4, I believe it was Max Planck who famously quipped that science advances one funeral at a time. The implication being that old ideas and maybe obsolete ideas are slow to die. Why is it that humans in general are kind of slow to update the data sets in their mind? And you mentioned that maybe it's getting better now with a little more dependence upon, having a Google. You can search Google in your pocket now on your phone. So why do I need to save, these ideas? But generally speaking, it seems like humans are kind of slow to adapt to new data sets. Do you have any thoughts on that? Why that might be?
So I think one of the reasons is related to kind of I think what I call in the book generational knowledge. This idea that knowledge kind of almost proceeds kind of in this staccato generation by generation fashion. And the way to think about this is, and when we're young and when we're kind of in grade school, we're treated as generalists. We learn a whole bunch about lots and lots of different fields. We learn geography, we learn history, we learn all the different sciences, we learn math, we learn literature, we learn all these different things. And then, in order to kind of be good members of society, we need to become experts in something, and we need to specialize. And so as we kind of proceed through the educational system, we end up learning more and more about less and less. And then even after we kind of finish our education and we try to become even more experts in whatever our job is, we have to learn more and more about those areas. And so even though knowledge is changing rapidly and sometimes quite smoothly all around us, we don't realize it because we're kind of only in our little area. Until that is, kind of our kids come home and say, guess what? I mean, dinosaurs don't look like these slow green reptilian monsters. They're actually kind of these like fearsome feathered chickens. And you're like, oh my God, when did all this happen? And it turns out it's been happening all around us. But until we're kind of exposed to the kind of the next generation of information, we don't realize that. And I think, and it's because, and you can see this in many, many different things. And I think in the book I give an example of linguistic change. I'm kind of talking about how language change, and so you have like linguistic facts about what is considered grammatically acceptable or kind of certain terms of slang. And so the example I give is
your grandpa saying very, very fun.
Well, so he refused to allow. He said that my brother and I, when we said something is very fun, he's like, that is unacceptable. and it turned out because he grew up in a and actually even people probably probably only even like 10 or 20 years older than me, they also think very fun is incorrect. It just happens to be that there was kind of this relatively rapid shift. But since they came of age and learned language in a certain time when it was unacceptable, it looks very weird and sounds very weird when people start using language differently. And it's because of these kind of generational facts and how we kind of perceive things as fairly staccato when we interact with the next generation. I think the other reason that it's kind of tougher is because when we for many people, when they see knowledge that kind of conflicts with what they learned, there's almost, I wouldn't say a sense of dread. I think that's kind of an overestimation or kind of making it melodramatic. But I think there's a sense of kind of worry of like, oh my God, if something I learned is now false, like what does that mean for everything else I know? And I think what we need to do more is almost create this kind of like a sense of wonder. So like when you see so in science, and one of the reasons why when people read the paper, it seems as if knowledge is being kind of constantly overturned, it's because when newspapers report about knowledge, they're reporting about about science. They're reporting about things that are happening in the frontier. It's where the new discoveries are happening, and that's where it's where we know the least and where things are most subject to change. But it's actually where the most exciting things are happening. So for scientists, you want to see things overturned. There's almost a delight in things being overturned. And so one of my professors in graduate school told me this amazing story where he was teaching a course on it was on a Tuesday. Came in, lectured on some topic. On Wednesday, he read a paper that actually invalidated everything he had taught on Tuesday. So he came in on Thursday to his class and he said, "Remember what I taught you on Tuesday? It's wrong. And if that bothers you, you need to get out of science." And so I think there's like among scientists, we want there to be this idea that, okay, science is constantly in draft form, and we should delight in it. I mean, science it's a very human enterprise. We're constantly learning new things, and that's exciting. And I think if we can have a much more positive approach and delight in this kind of change, it'll be a lot easier for people to recognize and become aware and I guess and almost rejoice in this kind of knowledge change. And I think that's the kind of attitude we need to have.
That's nice. Yeah, I like that. Kind of reminds me of like Richard Feynman's approach to viewing the world. Like just kind of he always seemed like a kid that was just amazed to be learning things.
Yeah, the world is great. There's a lot of cool things that are constantly being overturned. Actually, and since having written this book, because I wrote about changing knowledge, all my friends constantly will email me things. Oh, like look at this new discovery. It overturned some other thing, and it's great. And well, one, I'm glad my friends are at least thinking about these kinds of things more consciously. But when I get to see all these different examples, it's really amazing, and it just shows how much there is left to learn, and it's amazing.
Yeah. So question number 5, there's a really nice section in your book about how to evaluate reported findings and scientific facts, studies. I'm not going to say like giving it like kind of a BS test, but just what are some of the good ways that a layperson that's interested in learning about the world and just getting smarter, evaluating statistics and reports as we're barraged with them?
So I think when you mentioned with statistics, I think that's actually one of the key points is that if you can, having a basic understanding of statistics and probability doesn't even need to be that sophisticated. I think that can be very powerful in kind of getting a sense of how knowledge is just generated and kind of the way scientists think about the world. And because it's really just kind of a little bit more fine-tuned way of just kind of being curious about the world in general. And the other thing I think for a lay audience to be aware of is that unless you're looking at a finding in a very, very specialized journal, especially the higher impact, the higher impact journals in science, they're actually aimed towards a fairly broad cross-section of scientists. And so in order for them to be readable, they're often, and they're speaking to their peers, but they're also speaking to a broad cross-section of people who are scientifically trained, but might not necessarily know that much about the other fields. And so I think one of the things that I don't think a lot of people are aware of is that if you at least have a comfort with kind of and a willingness to kind of look things up and say, oh, hey, here's some term I don't really know exactly what it means, and just like look up the terms in some scientific paper, it actually is not that. It's not that difficult. And maybe I'm overstating the case, but I think it's actually not that difficult to really read a scientific paper and understand it. oftentimes the barrier is less the jargon and more it's like jargon plus they're written in a very like
dry sometimes, yeah.
Dry, but almost like telegraphic way where it's like especially some of these papers where like there's a word limit or whatever, a word count limit, they need to kind of make things very compact. And so therefore a lot of information is packed into things and like the huge amount of information can be packed into like the caption of a figure. And I think once people realize that, and as long as you kind of just read it carefully, you can understand it, or even just in kind of read it like in different stages. Say, okay, first I'm going to read the abstract, and once I kind of understand the abstract, then I'll look at the introduction and the conclusions, and then if I kind of get both those, then I'll eventually look at the results, and then if I understand that, then I'll look into the methods. And and for a lot of scientists, I mean, I don't even know how many other scientists read papers that carefully. And I think it's more about kind of a willingness to say, okay, I'm going to try to understand it as best I can. And look things up if I don't understand it. But as long as you kind of have the tools of like probability statistics or kind of just recognizing that certain of the terms that are used in scientific papers are used in precise ways, not necessarily difficult to understand ways, but just precise ways, and you kind of can recognize that, they're actually not that daunting. It's more just kind of, it's like a mindset of saying, okay, science is not this exclusive province of scientists. It's actually, and it's really, science is less about the knowledge that we've created and more about kind of a way of querying the world. And so I think if you can kind of say, okay, they're just querying the world in a structured way, but they're testing things in the way that little kids test the world. And as long as you kind of say, okay, they're testing it, and I need to understand the words they're using to test the world, then it maybe shouldn't be that difficult. Then again, I could just be speaking from kind of having lived in the world of science for too long, and I have a difficult time judging the understanding. But I think that would be kind of one way of kind of becoming a little bit more comfortable with scientific papers.
Yeah, no, that's good. So Sam, we always ask at the end of the interview this bonus question about a book recommendation. What do you have for us today?
So this one book, I read it I think soon after it came out a number of years ago, that I love. It's by Mike Brown. He's an astronomer. It's called How I Killed Pluto and Why It Had It Coming. It's awesome. So Mike Brown, he's the astronomer who he discovered the object that caused Pluto's demotion from planet to dwarf planet. And so the book is about planets and dwarf planets and kind of the history, but it's also this very personal narrative about how he discovered these things, as well as kind of just about how science works. And so it's this really engaging narrative about his life and about what was going on at the time and kind of what the science behind it. And it really gives you, and I think it's unbelievably exciting. It's a really engaging read, but it also kind of puts a lot of these things in perspective. So for example, a lot of I was speaking to a high school recently, and I was talking to them, I think, about Pluto, and they were all like, yeah, Pluto's demotion was horrible because like that was like their favorite planet. And I said one of the things, first of all, I was always kind of a spacewalk when I was little, and I remember like looking at Pluto's orbit and like on these pictures, and I was like, that doesn't make sense. Pluto's this small rock and it has this bizarre orbit. It doesn't fit the rest of the planets. So when it was demoted, I kind of felt like, justice has been served. I know I'm
coming, yeah.
I know I'm in the minority, but one of the things that in this book it discusses is that it turns out this is not the first time this has happened. So when the asteroid belt was first being discovered, the largest asteroids, when they were first discovered, were large enough that people said, oh, well, these are actually new planets. And they were kind of added, and school children learned about Ceres and these other planets. And then they started discovering a whole bunch of asteroids, and we're like, oh, wait a second, there's actually an asteroid belt, and they got demoted. And so this kind of thing is not new. And so I think seeing these kind of like long historical processes kind of puts all of science into perspective, but certainly just the book on its own is a great read, and I highly recommend it.
Really appreciate that. Hey, Sam, it's been great talking with you. Appreciate you coming on.
Oh, thank you. This is a lot of fun.
All right, take care.
All right, thanks.